coordination compounds are a special class of compounds in which central metal atom is surrounded by ions or molecules beyond their normal balance. These are also called complex compounds. So please write. Let me put some ink in my pen. This hint of this type of compounds have started. Okay, people have prepared different types of compounds, having almost similar formulas. Say there are compounds of cobalt. This is found to be violet. Again, they have found this is, I may be a little wrong with the color. You can check from the book, dark. And see, they have found these three compounds of cobalt chloride having different color but have the same molecular formula. Okay, and this year too you are being deprived of your chemistry practical. Generally, when a salt is being given, and if the salt contains fluoride, how do you detect it? To the solution, we add silver nitrate solution. If you add silver nitrate solution, then you get a thick white precipitate. Generally, we call it cardi white precipitate. Okay. So now, when silver nitrate solution was added in excess to all these three compounds, here in this case, we have got 3 moles of silver chloride. In this case, 2 moles of silver chloride, because you can take the weight of the precipitate. You filter it and you take the weight of the precipitate. And here you got 1 mole of silver chloride. Then people become very, very strange. Then why it is happening? Same molecular formula, colors are different, but we find when we add excess of silver nitrate solution, they have given us different amount of silver chloride. And one more interesting thing they have found, when they have taken a compound H2PtCl6, we call it platinic acid. Platinic acid. To that, when they have added silver nitrate solution, they could not find no white precipitate. No precipitate was there. But mind it, there are 6 chloride ions there. Then they could feel these are not the normal or generally available salts, inorganic compounds. They are something different. So from that time, they used to call this compound as complex compounds or complex salts. Okay. So they behave altogether different from the normal salts that we have prepared in our laboratory. From there, this concept have started. All right. Now let's see how does this compound formation takes place. See, suppose, say in a beaker we have taken ferrous cyanide. And to that we have added potassium cyanide. Okay. Then after that we get a pale yellow compound. This. See, this compound you crystallize and again you dissolve in water. This is salt. Salt is supposed to ionize or dissociate in solution to give you respective ions. So we find here, very interestingly, a new ion. That is, in the solution, the presence of free In the solution, presence of free ferrous ion and cyanide ions would not be detected. And altogether, a new ion altogether presence of a new ion was found. Okay. Now see, we have added two different salts, and we got a compound. This compound, when you dissolve it in water, it does not give all the ions by which the compounds are being made. But similarly, if you have taken, say we have taken here potassium sulfate, and we have taken their aluminum sulfate. Most of the school, I think, coordination chemistry was done. Okay. Then here also you'll find it gives you a compound with 24 molecules of water. Okay. This compound, again, if you dissolve it in water, it has given us all the ions by which the compounds were formed. You can test potassium, you can test aluminum, you can test sulfur. So these two compounds are different from each other. Okay. This type of compounds are called double salts. So double salts differ from these complex salts. Okay. So let me write the name of this compound. This is called common. Okay, right. Noble salts are addition or molecular compounds. Which are formed by two apparently saturated compounds, but they lose their identity when dissolved in water. Okay, example, I have already written here potassium sulfate, aluminium sulfate, 24 molecules of water. This class of compounds are called elam. Okay, so this we call it elam, or which we call it common elam. This is the one which is being used for the purification of water. Okay, so what is the general formula of elam? General formula of elam. Please remember, it is M1. See, I am writing here oxidation state. It is sulfate, then this is oxidation state here. And it must have 24 molecules of water. So this is the common elam. Few examples you should remember. It is univalent metal and it is trivalent metal. So similarly, if I can take here potassium sulfate, see this is ferric sulfate. Okay, so we call it ferric elam. These type of compounds are used for dyeing or coloring of cloth. ये हम तुम लोग को बहुत चीज बता रहे हैं, तुम लोग तो समझता सुनता नहीं अच्छे से। हाँ, बाद में देखो एग्जाम में, एंट्रेंस के एग्जाम में आता है सब चीज। हाँ, सी दिस इज कॉल्ड chrome elam. Now you're a little unlucky because of practical is missing. Ammonium sulfate, ferrous sulfate, 6 molecules of water. This is the most common elam which is being used in up to class 12 practical also. This one. This is called Morse salt. Okay. Another one which you get in the nature. Potassium chloride, magnesium chloride. Sorry, dear, 2 molecules of water. Not 2, 6 molecules of water. Okay. This is the ore of magnesium. It's called carnallite. Carnallite. So these are the example of double salts. How do you know double salts? Because once you dissolve it in water, all the ions will be separated from each other and you'll find it in the solution. But in case of complex compounds, ions by which the complex is being formed, if you dissolve it in water, all the ions will not show their independent existence. But you will get altogether a new ion in the solution. So in case of the complex compounds, you will not be able to detect all the ions there. In double salts and common salts, the differences in the note that I have sent you, you will find it is there. Okay, so I'm not going to write all the differences. Clear? Now, let us know about the first concept given about the coordination compounds, or those days the name was not coordination compounds because people did not have any concept of the chemical bonding, nature of chemical bonding also. So they used to call it complex salts. It is called Warner's theory. Warner's theory. Okay. Postulates. Postulate means their proposition, whatever the concept given. So right now here. In coordination compounds, metals show two types of linkages or valency. See here, very interesting. Those days the concept of bonding was not there, so in that postulates, bond is not being formed, is not being mentioned. They mention about linkages or valencies. Excuse me. Primary and secondary. Okay. The primary valencies are normally ionizable. Okay, so let me write it here. CO H26 Cl3. CO H26 3 plus BCl minus. So this is primary liquid. Or let me write again here. K4 FeCN6 gives you 4 potassium ion and the ferrocyanide. This. The secondary valencies are non-ionizable. That is, they do not separate in water. These are satisfied by
Sir, what
neutral.
is that? Non, sir.
The secondary valencies are non-ionizable. These are satisfied by neutral molecules or ions. The secondary valency is equal to the coordination number and is fixed for a metal. Okay, so let me give you an example. Say it is this. In this case, you will find the 4 ammonia does not disintegrate. Okay, how does it look like? See, what is this coordination? Coordination number is what we have learned in solid state also. It is the number of the spheres or ions or molecules which surround the central metal. What is quotation number 4? 1, 2, Fe, CN6, 4 minus, see here, it is cyanide, 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 cyanide. See here. This is octahedral. Okay? 4 minus. What is this coordination number? I don't have space. You can write here. Coordination number 4. Coordination number 6. Okay. Then 4. The ions and or group. I will not write group. I'll write molecules. Bound by the secondary linkages to the metal have characteristic spatial. Spatial means in space. Arrangements corresponding to different numbers. Example, planar, square, square planar, tetrahedral, trigonal, bipyramidal, or octahedral. Okay. So now let me write. See, we have here, you use square brackets now, but in a compound you cannot have square bracket. Suppose I want to write, I want to show you the types of linkages in this quotation of bond. So let me write it like this.
Excuse me, sir.
Yes, sir.
What's that trigonal? And
Trigonal bipyramidal.
thank you, sir.
Okay. See, this is water molecule. How the water molecules are bonded to the central metal atom through secondary linkage. These are all covalent. Because of that, they do not break in water. See, this is the one. What is the structure here? Structure is octahedral. Okay, now. Okay, I will not write this one. You will have some confusion. Why I will not write, I will tell you. So these are the secondary linkages. Now see here. This one, cobalt here is 3 positive. Water are neutral, so water molecule cannot neutralize its charge. So in this case, suppose I write here Cl, Cl, and Cl. These are negatively charged species. See, these broken lines are primary linkages. These are the primary linkages. Okay, so here I will write primary. And the solid lines are secondary linkages. So this is the final form of our coordination compounds. So one is called coordination entity. It constitutes a central metal atom or ion bonded to a fixed number of ions and or molecules. Okay. Example, this. in this species, central cobalt 3 ion is surrounded by 6 ammonia molecules. Okay. See, this is iron. Suppose I have taken this nickel Cl4 2 minus. In this nickel 2 plus metal ion is surrounded by 4 chloride ions. Now, NiCO in this, see here, observe it, nickel metal. Now it is not iron, okay? Nickel metal atom is surrounded by 4 carbon monoxide molecules. So this is called coordination entity. Okay, now in order to neutralize the charges on charges of coordination entities oppositely charged ions are associated with them and are known as counter ions. Please remember this word, counter ions. Okay, example. See here. Cobalt 6, see 3 plus now. See here, 3 plus. You will find here Cl3. So, what should I write now here? Here you will have coordination entity. Okay, so we have here 3 chloride ions. These are counter ions. Counter ions. My question is that my students should know everything. See, in this case, 4K plus Fe CN6 4 minus. So this is the counter ion. So counter ions can be positive or negative depending upon the charge of the coordination entity. So, counter ions can be positive or negative depending on the charge of coordination entity. Second, central metal atom or ion. In a coordination entity, metal atom or ion to which a fixed number of ions and or molecules are bonded in a definite geometrical arrangement around it and is known as central metal atom or ion. Jesa? So it is this. See, these are molecules, these are ions. Okay, so this is the central metal atom. Here, central metal atom, it is ion. You will know after a few days. You can find out. I need not tell you. So it is this carbon monoxide. This is central metal atom. Third, this is important for exam. Ligand. The ions or molecules bound to the central metal atom or ion in the coordination entity are called ligands. This is ligand, this is ligand, this is ligand. These are all ligands. So if you consider your body to be the central mental atom or ion, then your hands, your legs are ligands. They are bonded to your body. Okay. Types of ligand. The ligands may contain one or more. See, these are the atoms which have donated electrons. So these are called donor atoms. More than one donor atoms for coordination with central metal atom or ion. Accordingly, the ligands can be classified as, okay, monodentate. See, this word dentate has come from teeth. Monodentate or unidentate ligands. Okay? Then B, bidentate or didentate ligands. Then polydentate ligands. Okay, I think all you have already done in your school, no? This quotation chemistry in any school it is not. Unidentate ligand. Unidentate or monodentate ligand. Ligands which coordinate to central metal atom or ions through only one donor atom are known as unidentate or monodentate ligand. Okay, so this may be neutral also, or so these may be neutral. Oh, that we have already written now. Written though. So now we'll write example. Okay. Neutral. What will be this? See here. Water. It will bind through oxygen. Then ammonia. It will bind through nitrogen. See here. Amine. It will bind through nitrogen. Then alcohol. It will bind through oxygen. Then carbon monoxide. It will bind through carbon. All right. So, etc. Then anion. Cation cannot donate electrons, so there you cannot have cation. So all halides. Say I write now halides. Oh, okay, I write here. Forget about fluoride, chloride, bromide, iodide. Then you can have hydroxide. You can have alkoxides. Okay? Then you can have very strong ligand, cyanide. So I'll write like this. Huh? Please remember, I'll put here negative sign. We'll write here cyanide. And here I'll write here it binds through nitrogen. We call it isocyanic. Okay, these I'll tell you separately. Then you can have here nitrate, nitrite, sulfate, carbonate, etc. Bidentate or didentate ligand. Ligands which have two donor atoms and bind to the central metal atom or ions simultaneously. Just like suppose you go for a hug, we use both the hands. Okay, example, I'll give you a little more because in your book, if I go to your book now, I feel very sad. I'll give you some more examples, which is for your entrance exam. So here also I write here neutral. Okay, the most popular one which is being given, that is also given in your book. See, they use the lone pair. So it is its common name is ethylene diamine, but we do not use this name. We write here ethane 1,2 diamine. No, I'll put bracket here. This is the common name, this is the IUPAC. Okay. Then see, this is we call it ethanol amine. That is, this will bind, this will bind, this will bind, this will bind. Okay. Then should I draw all these things? Then you feel a little bored, huh? অপরিজাত তো তোমার ক্লাস আছে নাকি?
হ্যাঁ স্যার।
কিসের ক্লাস?
স্যার স্কুল চলছে তো অনলাইন ক্লাসেস চলছে এখন।
এখন কিসের ক্লাস হবে?
স্যার ফিজিক্স।
ও কোর্স শেষ নাকি?
ফিজিক্স আর শেষ, ম্যাথস আর বাকি।
আচ্ছা। Now this is also very important. আর কেমিস্ট্রি কোর্স শেষ?
না স্যার।
Is called, this is being used profusely, huh? It's called dimethyl glyoxine. So these are neutral. Then anionic. This is called oxalate. Anion of oxalic acid. This is called glycinate. So you know this one. This is called what? Solvent. Okay, then I'll do next day.